As we begin our study of exponent rules, we need to know some of the definitions that are going to be used to talk about parts of our exponential expression. So here we have 3 raised to the 4th power. This whole expression, 3 to the 4th, is called a power. The 3 itself is called the base of the expression, and the exponent is the 4. If we expand 3 raised to the 4th power, this means to take the base and multiply it times itself 4, and that's what we get from the exponent. So base times itself 4 times. Sometimes we will have a coefficient multiplied times our power. So this would be the coefficient, so a number that's multiplied times our power. This is just the x itself is the base. Now that's going to be important. The a is not included, just the x is the base, and then n is the exponent. A is a coefficient. So if a power has a coefficient, then it's only the base that gets the exponent. And that means what we're going to do is to follow PEMDAS. So here we have 3 times 2 to the 4th. So this is our coefficient. And so the base on this is just the 2. So I'm going to take the 2 and multiply it times itself 4 times, and then the 3 is going to get multiplied times that result. PEMDAS, remember PEMDAS, the exponent gets done before the multiplication. So that's why the 2 to the 4th gets done before we multiply by 3. So we get 2, 2, 2, 2 gives me 16. 16 times 3 is 48. All right, so then our multiplication rule. If we're multiplying powers with the same base, for example, x to the 2nd power times x to the 3rd power, x is our base. If we expand that, x to the 2nd means x times x, then x to the 3rd, x times x times x, and then it's just straight multiplication. So now I have 1, 2, 3, 4, 5, x raised to the 5th power. So the rule that goes with that, notice that here I have a 2 and a 3, and I'm going to add these plus these, and I'm going to get an exponent of 5. So when multiplying powers with the same base, you're going to add the exponents. So x to the 2nd times x to the 3rd is equal to x raised to the 2 plus 3, which is x to the 5th. So just kind of mentioning right here that remember that when you have x squared plus x cubed, whenever you're adding terms, you have to have the same exponent. They have to have the same degree to them before we can add them. So you can do nothing to this expression right here because you can't add unlike terms. All right, some examples. Here we have 3 to the 4th times 3 to the 2nd. So 3 is my base. So when I multiply, my rule says to keep my base the same and add my exponent. So 4 plus 2. So this would be 3 to the 6th. When I have here y squared times y to the 9th, my base is y. I'm going to add my exponents to, if there's not an exponent, it's understood to be 1. So plus 1 plus 9. So that's going to give me 3 plus 9 is y to the 12th power. Sorry about that. Then f, example f, I have m squared times n times m to the 3rd. So when I multiply, remember I can use the commutative property and move things around. So I'm going to multiply my m's, the ones with the same base. So I'll be doing m to the 2nd times m to the 3rd, and then times n squared times n. So I'm going to keep my base for the m's, and I have 2 plus 3 is 5. And then times n, so keep my base for the n, so 2 plus 1 is 3. So I have m to the 5th, n to the 3rd for that answer. So remember that when you're multiplying powers, you can only combine the ones with the same base, and when you're multiplying, you will add their exponents. All right, so we have a multiplication of 2 powers here. They have some coefficients. we're going to multiply their coefficients. Again, it's like 4 times x to the 5th times 9 times x to the 3rd. So I'm going to multiply the 4 times 9 and get 36. Then I'm going to multiply my x's. And when I do that, I keep the same base and I add my exponents. So 5 plus 3 is 8. In example C, again, it's all multiplication. So I'm going to multiply my coefficients. 2 times 9 is 18. 18 times 3 is 54. Then I have an A, and I see here that's going to be an understood 1. So I'm going to add my exponents for my A's together. So I have 1 plus 2 is 3. And then I have a base of B, and there's nothing to combine that with, so B to the 4th. So that becomes 54, A to the 3rd, B to the 4th. So let's try one more of these. So C, never mind, I'm going to stop.